One half's working, so we're all set. So here, I'm just going to show you the answer sheet just so that you're familiar with it. All you need to do is so every answer is A, B, C, D, or E for all the questions. And then you just put one of those 5 answers in every slot. You're all set. And that's all you need to do for the test. So you're going to get this and one packet, which has all of the multiple choice questions attached to it. So the multiple choice questions do not have your name or ID on them. Okay? They're already printed, so I'm not going to change it. They do not have your ID or name on them. So should you just circle the answers on the multiple choice sheet and not on the answer sheet? No, because there's no way I'll be able to match them up later. So please, please, please write your answers on the answer sheet here and not on the multiple choice sheet. Any questions? Burning questions? Yeah. Right. Mm-hmm. So this is one of the harder questions in my opinion. So what does big O notation actually mean? The worst case scenario, but is it for all input sizes or just at some point one overtakes the other? At some point, the n squared algorithm, say, will overtake the O of n time algorithm. Think of it this way. Suppose that you just run bubble sort, and let's just say it runs in exactly n squared iterations, let's just say. And maybe we have another algorithm that runs in 1,000,000 times n iterations. So at some point, the n squared is going to eventually take over the 1,000,000 times n algorithm, but which one would you rather use in practice? Probably the n squared, because most input sizes are going to be faster for the n squared algorithm for what we're going to consider than the 1,000,000 times n algorithm. Just because that at some point the n squared algorithm is going to take longer than the other one, that does not mean that it's slower for what we actually care for. So best practice here means for what we're going to actually program for realistic input sizes. But you could also say that in theory, the n squared one's going to be worse because it will be eventually, but it's just that for most input sizes that we will actually care about, the order n one is going to be better. But so the test is not going to have a question like this. So this one was a little harder than what the test is going to have. But it's good for you to think about, just because that n squared does look worse than n, that does not mean that you should always pick the order n one, because sometimes the truth resists simplicity. Other questions? Yeah. 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 So it's just that some people, so that assignment 7 and assignment 8 are not fully graded. So, and I want to do them all at once. But once assignment 7 and 8 are graded, I'm definitely going to update them on Blackboard so that you can actually see it. But if you're one of the people who's not going to actually submit assignment 7 and 8, you know what your score is going to be, but it's just if you submit one of them, I can't necessarily predict. Maybe you do extremely well on the last 2, and I can't necessarily replace the other ones without knowing those scores yet. And I want to do them all at once. Do you know when those will be graded? I'm going to get on the grader for that. So I'll try to get the grader to do it as quickly as possible. It looks like assignment 7 is halfway graded, and not many people are submitting assignment 8, so hopefully that'll be graded really quickly, but I can't predict anything. Before next Friday, because I have to turn in grades then. But other questions? Okay, so I mentioned that I already printed off the test. So the test has, of course, 75 questions, but they fall into, I think, 3 main categories. So I don't know exactly how many of which there are, but there are 3 main categories. The main one of those 3 is I have an application, and I want to solve this problem. Which concept should we use to actually solve this problem? So it's not like whether we should use a pointer versus a vector or something like that, or an array. Something like, should we need templates for this problem? Should we need vector for this problem? Should we need loops for this problem? That sort of thing. Would those be helpful in solving the problem? The other group of questions is your understanding of the concepts themselves. So I don't think this is one of the questions, but one would be like, what is an R-value reference, for example? That would be an example type of that question. What was the third one? I'll try to think of it, but it's trying to assess your understanding of your ability to understand the material, as well as how can you actually apply the material. So that's what I'm trying to go for. I'm not trying to be very nitpicky about one particular concept versus another, because I already tested you on. Oh, here's the third type. I give you some code. What is the output of the code? Or I give you some code and it contains an error or not. What is the error and why? Or maybe there is no error. So it's your ability also to read existing code and figure out what's wrong without actually putting it into your computer and seeing what the compiler says. Okay, so that's the third type. So the 3 types are your understanding of the concepts and what the concepts actually are, reading the actual code, and then actually trying to implement something. What concept should you use to apply something to solve a problem? Okay, so any questions then?
Can you bring up the final review and you can look over which?
Oh yeah, that's a great idea. So let's do that. Okay, so any particular part of the review you want to look over, or everything? Okay. So we can start from the end and work our way back. So anything about exceptions, templates, STL, that sort of thing? So remember, the things that are not in bold, that does not mean that they're not on the test, okay? And in fact, some of them are. So the ones that are bold are the ones I want you to think about more versus the ones that are not, but that does not mean that the bold ones are exclusively the ones on the test. Yeah?
How helpful would past exams and tests help us with this?
I'm not sure what the question is.
Would they be more helpful about the same as just studying my whole notes, using past exams?
Of course, it can't hurt you to do that, but yeah, I think they would be helpful. So looking at the solutions of the tests, in fact, some of the questions refer to some of the assignments. So like in assignment, say 5, we did this. And I restated on the test, we did exactly this, this, this. Then what if we did this instead to maybe solve this problem? So questions like that. So looking at the old tests and old assignments are a good idea. I don't have any questions about the labs, but tests and assignments are a good thing to look at again. Any questions about chapter 16?
So for finding errors in the code, do you think we should focus more on studying syntax errors, or is it more focus on logical errors?
So some of them are going to be about syntax errors, and some of them are going to be about logic errors. Yeah, so and about equal weighting of both. Yeah.
Can you go over copy constructors again?
Sure. So where is that? That was Chapter 11. Oh yeah, of course. So, so copy constructor. So what is the copy constructor? What is it designed to do? Yeah. Right. Is it move something over or copy something? Copy. So I have an object of some type, maybe user-defined or int or string or whatever, and I'm trying to construct another object of the same type, or maybe a different type, but usually the same. And so the copy constructor says, I'm going to take the data that's over here and copy it over to this object over here. Okay? So I'm copy constructing the object. So let's just say we have a class, CP class, and then suppose we have a CP class object called A, or an object called A, and then maybe I want to copy construct A into another object B. So this will work fine for a number of reasons, but suppose that we wanted to actually figure out when is this being done? When am I doing the copy construction? So, of course, we have to make a constructor. Do constructors have a return type? No. So I don't have a return type for this copy constructor. And what does a copy constructor take by convention? A const reference, right. So a const CP class, maybe we'll call it other. And then this is the copy constructor. So in here, if I have some data members, let's just say we have a private thing here and a public thing here. Let's just say we have an int x, and then we can say rx is equal to other.x. And so this is going to copy the value x over to the one that we have. And so therefore, this will copy construct B in this case. This is giving us a different error because we don't have a normal constructor, but the point that I'm trying to make is the copy constructor takes a const reference to another object, usually of the same class. Okay, any questions on copy constructor? Okay, any other questions? Yeah. Yeah, static. So what is static supposed to do? The keyword static. Technically, yes, but where is it really used more? So let's just say we have a function here. Let's just say it returns an int. Maybe for some debugging purposes, we want to know how many times this function's called. So what is another way that I could figure out how many times this function f is called? Well, yeah, I can use a global variable. So I can say int num times is equal to 0, and then when this function is called, I increment num times, and then maybe I return it. Okay? So this function, every time I call it, it's going to give me back the first time 1, then the second time 2, 3, and so then I know how many times the function is called. What is a downside to using it this way? Using a global variable. Hint, hint. Yeah, it's cluttered. And what if I include some other library that also has a global variable called num times? So then there's going to be a conflict, an unnecessary conflict. What does static help us do? Yeah, you're actually technically right. But static says, I'm going to initialize this whatever it is, one time and one time only. So if I have a static int num times inside this function, then by declaring it static, this num times variable is declared and initialized exactly once. So when this function is called the first time, num times is created. Well, not technically, but we can think of it that way. Then num times is incremented, we return 1. Next time we call f, num times already exists because it's static. And then now we increment it to 2 because it already exists. What if I just remove the static here? what would this function always return? 1. But if I put static here, will it always return 1? No, and we can actually see this in action. So if I call f once and then maybe call it again, and then we'll see 1, 2. But if I take static away, then we should expect to see it 1 and 1, and we do. So static in general just means we initialize this object exactly once. And so, like for classes, if you have a static object in your class, then all instances of that class share that exact same object. So maybe you could use static for a version ID among all your classes, mainly among all the objects of your class, so you don't have to have a duplicate for all those times. Any questions on static? Yeah.
I have a question on loops.
Okay.
Can you give us a basic summation of all loops in each of their applications?
Yeah, so what are the main loops we have seen? Yeah, while loops, do while, and for. So, can I convert any while loop to a for loop and vice versa? Yeah. Yeah, what about a while loop to a do while loop? No, what is a do while loop guarantee versus a while loop? It executes at least once, where a while loop could be 0 times or more. So when is a do while loop a good idea? To have something that absolutely executes at least once, no matter what. What if we're printing a menu to a user? And if our loop, we can't guarantee it executes at least once, then a do while loop is a good idea because we want to print the menu for the user. Okay? Where would a for loop be a good idea? Yeah, if we're looping across something, right? And what is the type of for loop we usually use for that sort of thing? We're looping across some structure. The range-based for loop. We don't have a range-based while loop, for instance. So a for loop is mainly good for when you know how many times the loop will be iterated. But could I use a while loop for that same purpose in principle? Yeah, I could, but it's just about convenience. When is a for loop more convenient than a while loop? So a while loop is good for when you know how many iterations there are or when you don't know how many iterations there are. A while loop. It's usually used for when you don't know, because what you can do is say, I'm going to keep looping and getting input from the user while the value that was inputted is not -1 or some sentinel value to stop. But for a for loop, usually in the condition part, we say, this is a condition that indicates how many times this loop will be iterated. But in general, a for loop is when you know how many iterations is going to happen, and while loop is usually used for when you don't know that number. But of course, you can convert those back and forth, so it's not like one is better than the other always. Okay, any questions about loops? Yeah. Yeah. Mm-hmm.
So if you have a static variable in your objects, and say you have objects of the same class A, B, and C, and variable, so that A dot variable, B dot variable, C dot variable
Will be always the same. Mm-hmm.
And you have to still call them that way though?
Well, that's if you declare them public. If you declare them public, then you can use dot. But that's the way you have to access them. It's just a normal variable, but its scoping rules are different because it's static. It's not like it's a different kind of variable that can be accessed differently. Other question? Yeah.
Could you go over the importance of an R-value reference?
Yeah. So, what is the importance of an R-value reference? So let's just go back. What is an L-value reference? How can I distinguish it from an R value reference? Yeah. So an L value reference has a name. Okay? So if I can take the address of something, which means it has a name, it's a variable with some name, then it's an L value reference. Okay? If it's not that, what is it? It's an R value reference. Good. So when is an R value reference a good idea? Yeah. So what function have we learned involves R value references in some way? Not a pointer, a function name. It starts with moo and it ends with v. Move. So what does the move function do? Hint, hint. What does the move function do? It moves the contents of something into somewhere else. Does it actually do that? What does it actually do? It doesn't do a copy. It doesn't change the address, but it changes something about the object. So let's just say we go back to our CP class, business. Let's go back. And let's just say I leave the class completely empty. Maybe it has a move constructor, not important. But let's just say I'm going to call move on A here. What is it actually doing here? Almost. So what actually happens in the move function is it converts whatever was passed in. So what was passed in, an L value reference or an R value reference? L value, why? Because it has a name. Therefore, it's an L value reference. So, but the move function, what does the move constructor typically take as its argument? The move constructor takes a what kind of reference as an argument? An R value reference. So what do you think the move function does? It converts whatever was passed in into an R value reference, no matter what. And we can actually look this up. So let's look up move function C++. So if we look up the move function, yeah. So it directly returns the value that was passed in to be an R value. So whatever was passed in, it converts it to an R value. And we can see that here. There's this other business with it, but it mainly is an R value reference. Okay? So because it's an R value reference, it doesn't have a name anymore. And so we can take what was in there before and move it into the object B here. And so since I'm moving the elements out of here, it has a name. Well, it's not going to have a name for very much longer. So I'm going to move the contents out, and then therefore I've moved the elements of the variable A into the variable B. And so I didn't have to do an unnecessary copy. Yeah.
So when you move the contents of A to B, when you call the variable A, what happens? Is it null or?
So this will depend on the move constructor's implementation. Usually, yes, it will be null. It will be completely nulled out. So like if it has any pointers in there, all of them will be null pointer, and it has like no data anymore. Yeah.
So what's the difference between a function move and a move constructor?
So move constructor technically has nothing to do with move constructors, but all move does is it makes it become an R value, and then the move constructor expects an R value. So it doesn't matter how it got that R value reference, but move is a way to get it to be an R value reference. So for a move constructor, we want it to be an R value reference, and move is one way to do that. Other questions about referenciness?
Do you need a move constructor, or can you just use move?
well, this move right here, remember, there's an assignment happening here, so you need a move constructor somewhere. Here we technically don't because we don't have any data in our CP class, but if we have any dynamically allocated memory in there, then we actually do need to do the move and move the pointer across.
But if there's no dynamic memory, then you can just move things around.
That's a good question. I think you can. So if you have like some data members like let's just make them all public for simplicity. So let's just make all of these public, yeah. So there are some types that are called trivially copyable and trivially movable. And the main data types like int and long and those data types, those are trivially movable. And if you can determine that every element of a class is trivially movable, then you can always move over. Yeah. So it depends on the actual class. This is going way beyond what you'll ever need to know about this. The point is, understanding what the move function does, it converts things to R-value references, and that the move constructor expects an R-value reference. That's all you really need to know about that. Other questions? Yeah?
Can you explain the virtual function question on the list?
Mm-hmm. So what is virtual designed to do? Or what is its purpose? Not all at once. So where is virtual used? Yeah, it's used in inheritance. So what is the purpose of virtual? Yeah. Right. So if I did not have virtual at all, and I had a superclass up here which had some function, let's just call it f, and then the child class also has a function called f, what happens if I make an object of the child class and call f? Does it call the child's f or the parent's f if I don't have virtual? It will always call the parent. Although that's not true. If you make the type on the left side of the expression be the superclass, then it will call the parent one. It calls whatever was on the left side of the creation of the object. So maybe if we have an animal, some name equals new cat, for example, then if I call f on that animal object, it calls the f in the animal class, not the cat class. But if I make the superclass versions virtual, then what happens? Then it will call the right one. It'll actually look up the type of the actual object. It would normally just see, oh, it's just an animal object. It could be a subclass, but all I see is an animal object. But if I put virtual in there, then it'll say, are you a subclass of animal? And if so, I will call the right one. I won't just immediately call the superclasses version. So what is that type of behavior in general where it calls the right version? We learned a term for this, and it's a pretty important term. Something to do with poly and morphing? Yeah, polymorphism. Yeah. So virtual on functions just means we're going to achieve polymorphism. If we have objects of a subclass, it will always call the function in the subclass, not immediately go to the superclass. So is this the question you were wondering about? Is this the question you were worried about? Yeah, pure virtual. So what is the difference between, what's the difference between virtual and pure virtual? What does pure virtual not have that virtual functions do have?
And just the virtual, doesn't the superclass have, like, it does have a initialization that is like kind of the default if you don't have one of these virtual, but in a pure virtual function, it doesn't even have that, so it forces the subclass or something.
Exactly. So a pure virtual function has no implementation at all. It has no implementation. Whereas a function that's not pure virtual, it has some implementation. It might be empty, but it has something there. So if we have a pure virtual function, should I be able to construct an object of that class if it has a pure virtual function? Well, probably not, because if I construct it and call that function, what is it supposed to do? It doesn't have an implementation to run. So there's no reason for me to be able to construct an object where it has a pure virtual function. So a pure virtual function is in a superclass where the child classes do provide an implementation. The child classes have just a normal virtual function, not a pure virtual function. So the superclass should not be constructed directly because it has a pure virtual function. And this forces the subclasses, or at least some subclass, if I want to actually construct this object, to override the function. Why is it not this one? Yeah, override versus overload. What's the difference? Hint, hint.
Overloads with functions.
Yeah, overloads with, well, actually they're both with functions. Yeah.
Overload would be with a different set of inputs, whereas override is different.
Yeah, so overload is the same function name, exactly the same function name, but for overload, the signature is different, meaning that either the number of parameters is different to the function or the types are different. So if it's like int for one version and int string for another one, that's an overload because it's a different type for the signature of the function. For override, that's when you have the same function name and the same signature. But one is in a parent class, one is in a child class. So you're changing the behavior of the function in the subclass. That's all that's happening there. So overloads across functions, either across hierarchy in the inheritance chain or just no inheritance at all. But override always is with inheritance, always. So that's another difference, but yeah.
So for one of the questions that was about static dynamic, can you explain the difference between a base and a superclass? The answer is the exact same, but in your slides you state that like superclasses and alternative way of saying things.
Yeah, so a base is the superclass, always. And then, yeah.
So then what's the difference between
I meant to say subclass here. I'll fix that. Yeah, so both of those should be right. Yeah, so this one, yeah, a base and super, parent, all those are the same thing. Yep. Yep, my mistake. I'll fix that. Yeah.
On the pointers and references question, you said that they were the exact same.
Mm-hmm.
Don't pointers, aren't they able like to be like, can references be outputted to both
Yeah.
dynamic memory,
So-
things like that, or
So this is,
it seems to me like they're not the exact same.
right. This is kind of a trick question, and I kind of apologize for putting it in. It should have said pointer variable and a reference variable. A reference is just an address. A pointer is an address. So they are the same, but a reference variable and a pointer variable are different. So for a reference variable, if I pass the reference variable along, I'm just passing the address along, so no issue there, but I still have access to the underlying object immediately. I don't have to do any dereferencing. With a pointer, I have to do the dereference. So that's for a pointer variable and a reference variable. But a pointer and a reference, those are both addresses, so they are the same thing. Yeah, so yeah, that was kind of a trick question.
Dynamic memory with the reference?
No, because for a dynamic memory allocation, it always gives you back a reference. It gives you back a pointer. And so you need to make a pointer variable for it. And in fact, it won't actually let you make a reference variable for it. So it has to be a pointer variable in that case. Yeah.
Isn't heap with dynamic memory?
Yeah.
That's why I put that one.
Yeah, so heap, I mentioned, is for dynamic memory allocation.
Yeah, so probably a lot of people put that.
Yeah. Yeah, I'll take a look into that too. I assure you, no question on the final is going to be ambiguous like this. I've already looked. I guarantee it. Fingers crossed. Yeah. Sorry, I couldn't hear you. Predicate. So what's a predicate? It's not just a bool. What else is it? Yes, in a way, but like, what is the underlying thing there? It's a function object underlying the whole thing. So what's a function object? So a function object is just an object that you can treat like a function. So if I want to make some CP class variable, let's just say A, and then if I want to be able to call A like this, like a function, I need to convert this class to be a function object. What is a special type of function objects that we've seen? Lambda, right. So a lambda, remember, is just a function object and returns something. So maybe we can make a lambda right here. So let's just say it takes two integers, and then it returns whether x is greater than y or not. So this is a predicate. So because it takes parameters and it returns a bool based on something related to those parameters. So is this a unary predicate or a binary predicate? Binary, because there are two arguments. So a predicate in general just means it's some function object, a lambda or not, and it returns some bool based on some condition that happens. Yeah.
Can you give an example of what computational problems or basic vectors can solve that you could do without them?
Yeah, so an example, so this is one of the quiz questions. When can vectors or arrays solve problems when otherwise you can't? It happens when the user inputs the size of the vector or the array. So let's just say they enter an integer n. Do I know what that size is before the program runs? No. So can I duplicate the code that many times before the programs even run if I don't know the size? No. So there's no way that I can actually check the size of the array or how many times I need to duplicate code or anything like that at compile time before the program actually runs. So if you need to actually store the value somewhere, then arrays and vectors are needed in some problems, namely when the user enters something. If I know that the size of the array is 100, for example, could I, in principle, just duplicate the code 100 times and maintain 100 different variables? Yeah, I could, but would I want to do that? No. So it's mainly in user input. Other questions? Yeah. Yeah, so what's the purpose of overloading operators, quickly? Yeah. Yeah, all it does is improve readability. There's no purpose other than just making it easier to read. So I don't have to call some variable dot some function name something. I can just say a plus b and make it easier. Other questions? Yeah. Yeah, all typedef does, so that's not on the test, but it's just for your knowledge. Typedef is just an alias for a type. So if I want to name something to be something else, then I can use typedef. So an example of this would be, so if I want to call another class to be CP class, then I can just use, oh, I got the order wrong. I still have a few seconds. So then I can use another class instead of CP class. Okay, well, the class has been a lot of fun. This is one of the most rewarding experiences I've had. Thank you for taking my class. I'll see you at the final.